Hello and welcome everybody. This is the MATLAB and Simulink Racing Lounge. Today we are going to talk about virtual test driving. And I'm really happy to have again a partner on board. So it's not a Formula student team, but it's Prasanna Kannan from IPG. Hello Prasanna, how are you doing?
Hello Christoph. Thanks for the invitation.
Yep, I know that you are partner of MathWorks, because your IPG CarMaker, which is used by a lot of Formula student teams, has a very nice Simulink interface. And really happy that you agreed to join the episode. Could you introduce yourself briefly?
I'm Prasanna Kannan. I'm part of the CarMaker service team here in IPG, responsible for worldwide support of CarMaker, truck maker, and motorcycle maker, family of CarMaker products.
So today's agenda, we will firstly introduce you to IPG support for Formula Student. They are quite involved there. Then we will have a very extended software demonstration. So thanks to Prasanna, he will guide us through all the relevant tools. At the end, we will talk about the recommendation for you guys. So what you can and should do using Simulink and the IPG CarMaker. And last but not least, we are critical to ourselves. We talk about the key takeaways, about the good and the bad things we have experienced so far. Prasanna, it's on your side. The stage is yours. So how does IPG support Formula Student actually?
Yeah, I've come with some kind of slides for this. We've been involved with Formula Students ever since 2006. Right now, I could say we have about 100 plus teams who have registered for Formula Student support from our side for the Formula CarMaker product. And we offer 2 software licenses per team. So every team gets 2 software licenses, which is valid for a year from us. Along with this comes tutorials in different forms, text, videos.
Okay. Let me ask the question at that point. So the software licenses, are they, cut down versions for students, or is it the full-fledged thing that also commercial customers could purchase?
No, actually, these are the full-fledged license. We call it as a CarMaker Pro, CarMaker Professional. So this is exactly what is used in the industry.
Okay.
And we offer 2 of these licenses, 2 user license for the team.
Okay, that sounds great. Thanks.
And in addition to this, they also can use our email support. They can shoot emails to our support team here, which is Formula CarMaker at ipg.de. And we make their job easy by providing them samples, project folders, application examples, etc., etc. We also conduct 2 training courses in a year here at Karlsruhe, and this is free of charge, and teams can register for these training courses and then attend to enrich their knowledge in Formula CarMaker.
Okay, perfect. Well, trainings in Karlsruhe, how should teams apply? Should they drop you a mail at Formula CarMaker at IPG, or are there other ways?
There are ways to do it. The easiest would be to log into our website, which is www.ipg.de, and navigate themselves to the Formula CarMaker page.
Okay.
And there is a registration for the training activities.
Perfect. Great. So let me ask 2 questions at that point, because what we are getting as feedback from the Formula student community, there's always a lag between the current IPG CarMaker version and the compatible Simulink version. So what is the current state? Which version of Simulink or MATLAB and Simulink can I currently use to run the IPG CarMaker?
Current version of CarMaker supports MATLAB 2015A.
Okay.
And of course, the Simulink version corresponding.
Yeah, which is the latest version. So you guys are pretty fast in adopting your CarMaker products to our latest release. Another question is, there has been some issues with 32-bit and 64-bit in recent times. So can you comment a bit on that?
This used to be a scenario before where we supported only 32-bit installation of MATLAB Simulink.
Okay.
That is no more the scenario. We have also adapted ourselves to the 64-bit version of MATLAB, so students can feel free, and probably the next version or the next edition of Formula CarMaker, they have the flexibility to use 32 and 64-bit versions of MATLAB.
Perfect. Sounds great. So it seems that there are almost no restrictions anymore. You can run the latest release. You can go for 64-bit versions, which, is a common standard. Good. Thanks for introducing us to that. And I think now we are already ready for your software demonstration. Really looking forward to that.
Thank you. Probably I'll proceed to that. Prior to that, I would like show you what I have in store for you.
Okay.
So I've come with a three-level software demonstration. The first to start with is a generic model with Simulink interface. So we show you the Simulink toolbox and the Simulink CarMaker for Simulink interface as such.
Mm-hmm.
Further, moving on, we show you how to extend your own model. This means like if you have your own model in Simulink and you would like to plug it in with the CarMaker environment, so how to extend extend the environment and bring in your own models. This is shown in the second example.
Mm-hmm.
Further moving on, whatever you did in the second step, like the model which has been extended, how to generate code out of it and probably port it to a special target, special ECU targets, or special microcontroller targets, etc. How to do this. So these three subjects probably is what I've planned for you,
Mm-hmm.
and I think this is going to be interesting for the students who are looking forward for such a demo. Okay, so as you see, this is the MATLAB environment, and I've started the environment with a particular project folder. The project
Mm-hmm.
folder is something very specific to CarMaker environment. This is where you store all your test runs, vehicle data, parameters, recordings, etc., etc. And this is exactly the place where the results are also stored. So after the simulation, if I want to save the results, they are also stored in the project folder.
Mm-hmm.
So the project folder typically looks like this. What you notice on the left-hand side here, the current folder, and the folder of my interest is
Mm-hmm.
src underscore cm for SL.
Okay.
CM for SL means
Quick
CarMaker for
question on that,
Simulink.
Prasanna. Sorry. Are there any folders that are not interesting at all for guys working in that, or do they all have a certain meaning, or what is the working folder here?
The working folder is actually the one which is FS Generic
Mm-hmm.
5.0, which is a
Yeah.
complete folder here.
Okay.
And every folder is used for different purpose. So
Mm-hmm.
bin is where you store your final executable.
Mm-hmm.
Data is where all the parameters are stored, etc., etc.
Okay.
So uh, right now for today's demo, I think source CarMaker for Simulink is where I'll be working. So I
Mm-hmm.
think this is of interest for today's presentation.
Okay. Perfect.
So once I move into this folder, I can see that there are different C files,
Mm-hmm.
MATLAB M files, models, etc., etc. So these are all templates which has been provided by us. So
Okay.
to make your job easier, these are some kind of examples which is available, and each of these examples is detailed in the documentation. So if
Mm-hmm.
you want to read more about these examples, you can actually navigate yourself to the documentation and then see what they exactly mean.
Great.
And
Mm-hmm.
what is of my interest today is this generic.mdl. The generic MDL is a bare minimum place to start with. So we'd call it as you need these things, these three blocks to do a car to work on CarMaker for Simulink. So,
Okay. Mm-hmm.
and here, if you see, these are different blocks here, and Open GUI is one which if you click this, then it starts CarMaker front end. So the front end GUI is movie, IPG control, which is used for data analysis, etc., along with an instrument which gives you a cockpit feel from the vehicle started.
Wow, interesting. Let me ask a question at that point. So this instrument board, is it pre-built, or can I do that in the CarMaker itself? So where did you create?
Good question. Even most of our experienced users don't know the background about this instrument. The instrument is actually programmed in a programming language called TCL,
Mm-hmm.
TCL/TK. The program behind or the script behind is also provided with CarMaker installation. So this means you can take it as it is and further extend it or go into the script and probably read them to understand it. You can build your own instrument out of it. So this is completely open source. We provide you with every CarMaker installation script for the instrument here.
Okay, interesting.
I,
Thanks a lot.
I'm just minimizing the window so that I can show you the model in detail. So when I open the model here,
Mm-hmm.
so as you see, this is the MATLAB, the Simulink blocks for the CarMaker model. So here is where the link to the model is available. So various parts of the CarMaker model can be
Mm-hmm.
viewed here. There are different signal access points here, so we can see what the signal flow, what are the values, etc. To start with, the model looks like a flow of events. So starting with the CarMaker first, so it's kind of an initialization. So if you read in any values and write any default values to them or some kind of constants, etc., this can be done on this block. Further moving on is the dripman block. Dripman means driving manager. Further on is the vehicle controller. So here you can have different type of control system which is added to the vehicle, like an ESP system or ESP electronic stability program.
Well,
Such
this is
kind of
also the
system.
block where I've seen a lot of guys in Formula Student working in, like TU Delft or EQRX or Steigstrom. Well, guys using your software have always pointed me to that block and said, well, here's our custom-made controller.
Most of the controllers find their place in this vehicle controller block, and here is where most of the signals are also accessible for some kind of a vehicle control action. Yeah? And then further moving on is the IPG vehicle. So here is where the physical models, typically the car and trailer, brake, powertrain, so everything which comes to the physical aspect of the vehicle model is placed here. And here, if, for example, if I navigate into the brake model, I can access different brake signals pertaining to the brake subsystem, like the wheel pressure, the master cylinder pressure, torques, etc. And if I have my own vehicle model, or my own brake model, sorry, this will be finding its place here, that you see here as your model here. We're going to talk about this in the later stages where we show you how to bring in your own model. But for students who have their own brake model, please remember this is the place to take it.
Okay, thanks. Great.
Further, it's the same with powertrain here. I think it's self-explanatory.
Yep. Okay.
Further moving on is CM last, where you want to de-initialize the values which you have initialized prior to the first simulation, etc. Cleaning the environment, etc. So if you want to access the signal, so imagine if you want to access the brake torque going on the front left wheel, so you can access it at this level. So this kind of interactions can definitely be done. Okay, so imagine if the environment is running on a hardware in loop system, then probably on the same flow we need to have I/O signals, which is like reading the voltage signals or current signals from the I/O cards, and then this is done at prior to the same first environment. So you read in the signal, and writing back to the I/O cards is done at this level. So this is after the end of the simulation cycle. CarMaker main GUI gives you an option to fine-tune each and every parameter which is available in the model, or ideally parameterize the model. So here, parameterization, when I say, so I have a demo vehicle here, when I click in here, then I have the parameters for this vehicle. So the parameters are typically the masses, inertia, their position, etc.
Okay. What I'm reading here, it's a FS underline race car. So is it already resembling a Formula Student race car?
Yes, spot on.
Okay, cool.
So this is a demo which we provide as a part of a Formula Student support package.
So basically, this is the starting point for Formula Student teams. So they had they have at least a certain model of a Formula Student car available.
Yeah, and these are also kind of more or less replication of a Formula Student car. And you see, for example, the weight of this Formula Student car, the overall mass of this Formula Student car is 332 kilograms, roughly the same category of a Formula Student vehicle. Okay, so further moving on, you see different types of systems can be parameterized, like engine, suspension, steering, tires. Tires could be, I think, of very good interest for the students.
Exactly. I know that Formula Student community is very interested in tire modeling. Can you comment a bit on what capabilities users have? So what kind of models they can use for that?
Interesting. As such, we have also seen Formula Student teams express a lot of interest in tire modeling. Yep. So we support different type of tire models. To start with, we have the real-time tire, which is based on a Tidex measurement. So this is you conduct measurements on a Tidex test bed, and then this measurement is directly imported to use it in CarMaker.
Okay.
Very similar interface. You have a .tdx file, and this TDX file is used for the further simulation of the model. We also support the Magic Formula 5.2 and the Magic Formula 6.1 tires, which is the Prasanna based model.
Well, exactly. We have used
modeling.
exactly that model in one of our Racing Lounge episodes, actually covering tire modeling. So we've also worked with the Magic Formula. And for you guys, in case you have data, either from the Test Tire Consortium or you have tested it on your own, yeah, you can use this data for the CarMaker as well. And the good thing that I'm seeing here is the Delft tire model, which is also, well, quite popular. So it seems that the IPG CarMaker is ready to deal with the most common tire models around. So great to see that.
So all the commonly used tire models in the industry is supported by us. So
Perfect.
as you just mentioned, TNO Delft tire is also supported. Tame tire, which is also very popular tire model from Michelin themselves, is also supported in CarMaker. So it's students have a total flexibility of adopting the various approaches and to make their own tire model.
Good. Sounds good. Thanks a lot.
Yeah. Similarly, is the brake modeling. So you have different type of brake modeling approaches. So a typical hydraulic system. Then, if you have some kind of an ESP based system, then you can also have the ESP parameters here selected.
Okay, so we have a model prepared for that as well.
Yes.
Great.
And the powertrain, which has also been ramped up now, you can have hybrid and electric powertrains also
as well. Okay. Well, that's a very good news for the electric teams out.
Exactly. So this version, the new version of CarMaker supports both hybrid configurations and electric configurations.
Perfect.
Then is aerodynamic sensors, etc., etc. So you can have different type of ADAS sensors. You can make your car really intelligent by having smart sensors placed at different points of the car. I don't know how much this is relevant for Formula student activities, but probably in future this might be interesting for even the Formula student context.
Exactly. Before talking about that, or before not talking about that, I'm very interested in one thing. I've seen in the IPG CarMaker, the car is actually driving, following a road. So there must be something like a driver. Is it a controller? Is it a driver model? So how can I imagine that?
Very good question that I was about to start talking about driver. Thanks, Christoph.
Very good.
So, the driver model in CarMaker is a very detailed model. So, as you see that there is also a GUI to parameterize it. But in the background, there is a very detailed model which takes into different kind of behavioral aspects of a driver, not just some kind of matrix you build a driver model out of it. But here we try to capture different behaviors of a driver. So when I say behaviors of a driver, so I have different parameters to configure the driver. So this comes like cruising speed, like what is the cruising speed of the driver, how much time does it take to change between pedals, like how much time does it take to lift his leg from an accelerator pedal and press the brake. Such kind of things can be parameterized. Further on, what is the maximum acceleration in longitudinal and lateral direction he can achieve. So this talks about how aggressive or how defensive the driver is. For example, I can go in here and select a defensive driver. So this is typically an old person driving very carefully, and he is not taking the car to its limit. Unlike if I select the parameter as drive as aggressive, then this is typically a person who is taking the car to its limit. So which means like driving at high speeds, at higher acceleration in both longitudinal and lateral direction.
Well, so at the end, we can say it's a controller, yeah, but a very sophisticated parameter set.
Spot on. And you also see there is an option to configure the gear shift. So I can select here how should be the gear shift for different gears. Like when should he shift to the next gear, when should he shift down, etc., etc. All this can be done. There is also an inbuilt traction controller available as a part of the driver model. So he controls the gas pedal based on the wheel spin, etc., etc. Further on, there is also a racing driver. So racing driver is kind of an advanced driver model. And here you have to allow the driver to learn the car on his own. So which means like you do a set of adaptation procedure. You follow this procedure, and then the driver learns the car on his own. This is very typical to how we drive a car. When we drive a car which we have not driven before, for the first few kilometers we are very cautious, and we kind of learn the limits of the car. This is exactly what IPG driver does under this, and we call it as driver knowledge. So the knowledge he accumulates is later translated into parameters for the driver model.
So this question is probably going a bit too far. So would there be the opportunity for Formula student teams to take data from their driver, so to log that data and calibrate the racing driver model in IPG CarMaker?
Yes, they can do it. They can actually start with the user parameterized driver, and probably try to get the GG curves of their real driver to match with that of the IPG driver, and then when they are successful, then take the next step to have the racing driver parameters. The racing driver will require more parameters, so it's better they take the first step with user parameters. I believe it was a good overview of the parameters in an IPG environment. So let me start the first simulation. Start. I just have to press start button here. See the preparation. It prepares this model, the background, and starts the first simulation. So you see the 3D visualization of the environment in IPG movie. We can see certain quantities here. IPG control, which is typically the brake pedal position, clutch position, gas position, etc. And on the instruments, we just saw how the instrument we are able to see the tachometer and kind of a cockpit view of the vehicle.
Well, it was something like an acceleration for a certain time, and now it's braking, and now it's standing still again, right?
Exactly. So the maneuver, we call it as maneuver in CarMaker, and the maneuver here is to drive for 400 seconds or to accelerate for 400 seconds, followed by 60% braking. So this is exactly what we just did in the first demo. And here, for example, I can manipulate the view of the road. I can change the different speeds. For example, now instead of doing it at 60 kilometers per hour, I can do it at 100 kilometers per hour. Instead of pressing 60% braking, I can do 40% braking. All of this can be done by changing the maneuver here. And I don't have to move into any kind of environment, Simulink or etc.
Well, this could be, for example, a setting where teams are starting, they try to make concept decisions, and they are simulating certain maneuvers. So I think now it's time to move over to the situation where teams have developed a controller and want to interface that with their car. So something, let's say, sophisticated in terms of braking or powertrain or vehicle dynamics. How can they do that?
So to start with, I would probably show it in a Simulink environment here. So I can actually go in here and, for example, disconnect the brake signal. So my brake is disconnected. So now when I simulate my CarMaker model, I will see here that the car will be simulated. For example, I can run the simulation 2 times faster, or 2 times the rate time, so that I can see the resistance much quickly. Accelerating, now he's going to brake in some time. He's braking, but the vehicle is not stopping. He's just coasting down.
Okay.
This is all because I've disconnected the brake signal here.
Yeah.
What I can do here is I can have some kind of an accelerator or some kind of cruise controller. So this is instead of the driver pressing the gas pedal, this gas pedal signal is coming from a controller. Kind of a simple P controller I have here.
Okay, but this nicely illustrates how you can interface your control algorithms with the CarMaker infrastructure.
Yes, exactly. Now I can start the simulation. You can see that Simulink is also running in co-simulation, so I can validate this control model with CarMaker. The same test run which I just used sometime back.
Okay. Great.
Now, so imagine if you have fine-tuned your controller and you have the best parameters in your controller and you would like to plug it into the CarMaker model, then you can use the CarMaker plugin mechanism. If you find it in the CarMaker library, CarMaker Simulink library, and you can use this block. Once you start it, you get options to plug your model in. So select the version. So you can select if it is 32-bit or 64-bit, type of vehicle, car, truck, or motorcycle, type of model here. So here's your favorite vehicle control model. Or if you have a model, say if you have your own suspension model, then you can plug it into the suspension model. And then you can give here a name here, demo vehicle control. Then you can give some model description like demo vehicle control. Then you can create, once you click the block, create, then you can have your own vehicle control block or the vehicle control model. Here you can access different car maker signals from here. For example, if you want to access steering torque or steering angle, gas, etc. Let me take some signals like gas, speed, steering angle, for example. Then you can plug in your model here and then compile the code out of it. So this means like this model will then be plugged into the car maker environment.
Okay, just to summarize, what you have done, you have used the controller that you have developed in the big window, and have created a plugin out of that.
True. So imagine if this is my controller model,
yeah,
then I can introduce into the plugin. This is typically what I've done on the CarMaker for Simulink environment, further moving on into the plugin-based approach. And once I've done this, I can further go into code generation and generate an executable out of it. I think that is next thing what I would like to show you.
Okay. It means moving over to the third part of the software demonstration, so how to get code out of that that actually could run on your controller, for example.
Perfect. Okay, now I'm going to show you how to integrate your own model, typically the model which you used in the previous step using the plugin mechanism, and then generate code out of this model. So I have prepared an example which here is a user steer model. So the steering system is coming from the user as it is. So he has built the steering system in Simulink. So the model is here, for example. So this is a very basic steering model. I'm going to show you how to generate code out of this model. Code generation process. For this, I start the configuration parameters of Simulink coder. Here, I can select, for example, typical settings like solver, what is the sample time, the step size, etc. Here is where we have the CarMaker extension, where we have a CarMaker.tlc, a target line compiler, is able to generate code out of the Simulink model.
Okay, yep. So as you've said, right, you're using Simulink coder, and with this TLC files, this is basically an instruction set for the code generation. So you could also run with a default TLC file that is provided by the Simulink coder, and it creates ANSI C code, so ANSI ISO compatible C code. And with the TLC files, so this is exactly what CarMaker has done, you can customize the resulting code to your needs. And basically...
Exactly. I think these codes can be customized for different applications. So the CarMaker.tlc generates code which can be plugged into the CarMaker model, and CarMaker executable can be generated out of it. So this means the executable contains CarMaker model plus the user model. In our case here, the steering model. So here, I can specify in this CarMaker block what type of a vehicle type it is, which model should this be plugged into, what is the model description. So you can have your own description here.
Yep.
And once I've done this, I can go in for the build option here, say build. Once you click the build option here, the model is translated into C code, and then the C code is further compiled to generate an executable. See here in the view diagnostic, there's a detailed description showing how the model was compiled, what is the library which was generated.
What kind of files have been created, where the C file, the C code is living. Okay, just an amendment here, a short remark, in case you are interested in that. So the TLC means Target Language Compiler. As said, you can customize the code generation process. Some area where it's really commonly used is when, for example, you want to inline code in S function blocks.
Yes, and for example, the model which we used just now has been converted into C code, and you see the C files here. What is interesting here to show is we were able to generate a CarMaker executable here. So CarMaker Windows executable out of this C code which we use. So this can further be extrapolated for different controllers. So when we move on to hardware in loop simulation, we can generate also an executable for a real-time system. So this is a similar approach which is followed further.
Well, real time should ring a bell for you guys. We've had an episode talking about Simulink real time, just the last episode. And there you can see that this code generation is really massively used, and it's a very powerful tool here.
People who are not much familiar with the real-time environment of CarMaker or IPG's real-time environment, we have a product line which is called XPack 4, and XPack 4 has a very similar environment, can run CarMaker on a real-time level, and there again we can use similar CarMaker.tlc target line compiler and generate executable for this CarMaker XPack 4 platform. So you can generate real-time executable from MATLAB, and this can run on our real-time environment exactly the same way how it is running on a Windows environment.
Great. Prasanna, thank you very much. This was a very extensive, but very, very good software demonstration. We have tried to cover as much as possible for you guys. Prasanna, you definitely managed to do that. Thanks a lot. Let's go back to the slides and do a quick recap of what we have done, and then move on with our episode.
A quick review. We used the CarMaker Simulink interface with a generic model, and you just saw how to co-simulate CarMaker and Simulink. Further, moving on, we were able to make model extensions. We took a very simple controller model and then integrated in the vehicle control plugin approach. And then this plugin was further used for code generation, and this was done for a typical steering model case.
Okay, great. So exactly, moving to the IPG recommends section, because what we've seen is covering a huge range. So what is your recommendation for starting teams that have never used the IPG CarMaker before, and what would be your recommendation for power users? So can we comment a bit on that?
The suggestion for teams who are just starting would be to take the generic parameter set and do concept decisions based out of it. So you can actually see in which direction the changes are reflecting. So if you do a small changes to the suspension setup, and you can see how the result in the lap timing is, how the car is responsive, etc. And further, for advanced users can use the same tool with a validated data set, a validated vehicle set, so which means that the vehicle parameters mimic the actual vehicle. And with this, they can do a lot of optimizations. One thing which comes into my mind directly is a lap time optimization. They can see how far they can go into optimizing the car to get the best lap time out of it. There is a predefined environment in CarMaker by which you can ask IPG driver to do lap time optimization. I don't know how many expert users are aware of this. If you're not aware, probably you should try it out. There is a special module available in IPG driver to do lap time optimization.
Okay, cool. Well, and the more sophisticated you are, you can move into code generation and even implement the control algorithms and implement the IPG CarMaker on your microcontroller, on your ECU.
Exactly. So you can generate software you can generate code out of CarMaker, which can be then ported on ECUs, or you can run CarMaker on real-time target and do hardware in loop simulation. Yeah. I think creativity is the only restriction.
Okay, sounds perfect. So I think now it's time to move over to the key takeaways, where we try to break everything down, to condense it down to 2 or 3 major statements. So let me go through them and ask for your comment, Prasanna, whenever I'm lost. So model validation in a virtual vehicle environment, well, this makes definitely sense. I think this is a typical situation for Formula student teams. They don't have a car at hand, but they have to make decisions. So the only logic way is to have a virtual vehicle environment for me.
When I look back my student days, when I used to participate in Baja, which is a very similar event, where we had a concept which we wanted to implement, but we were not sure how this would come in a whole vehicle perspective. So we never had a holistic vehicle in our mind. So we had only the components, and we had component models, etc. But with CarMaker, or Formula CarMaker to be specific here, we have a virtual vehicle environment where I can test my component models with a vehicle model. So this kind of a flexibility is what you get with CarMaker and Simulink in combination.
Perfect. Well, fast and easy extension of CarMaker models is clear to me. So we've started with a generic model. You've shown us two ways how to interface your own control algorithms there. Definitely agreeing with that.
Yes, I think once you have your models in Simulink or in C code, you can directly extend the CarMaker models with your own models. This is what you saw in the demo also.
Mm-hmm. Well, and last thing, support of the entire development cycle, mill, sil, hill. Two questions. What is the entire development cycle? What does it mean? And what do the abbreviations mean?
Here, to be specific with the development cycle, we start with the concept which is translated into models, and then these models are tested on a real vehicle level. So something from a concept to real vehicle. So this is what we call it as the entire development cycle. And the steps we here taken are MIL, which is model in loop, SRL, which is software in loop, followed by hardware in loop, which is HIL. So CarMaker is used at different stages. So you can have your own models of own controller models, for example, and then test it in a model in loop environment, which we just did today. And then there can be code generation done for this controller model, and then the generated code along with CarMaker can be tested in a software in loop environment. Further, they can be also translated to a hardware in loop environment, typically an XPack 4, and then you can do hardware in loop evaluation of your controller. But once this is all done, then thumbs up, the component goes onto the real car, and then you do a vehicle in loop level.
Perfect. Thanks a lot. And this last point reminds me of the episode we recently had for the Racing Lounge. It talked about code generation and the basics of it. So we have also a similar approach. We are mentioning, or we are using these abbreviations a little bit in a different way. But for you guys, it's definitely interesting to have a look at that episode as well, as we are touching all the code generation capabilities of MATLAB and Simulink there. And at that point, thank you very much, Prasanna, for joining that episode. Thank you for giving a massive software demonstration. Really enjoyed it. Thank you very much.
You're welcome, Christoph. Thanks for the invitation again. It was a pleasure to do this episode with you.
Okay, and this brings us to the end of today's episode. So we are really interested in your feedback. So let us know your comments and suggestions about this episode via our team email address, in case you think it should directly get to us and just to us. If you want to share your feedback publicly, just visit our Facebook group, facebook.com/groups/Racing Lounge. And well, if you want to see all videos of the Racing Lounge, I suggest to go to our dedicated landing page, which reads mathworks.com/Racing Lounge. And if you want to work with our software, you can benefit of our complimentary software offer, which you can find on our student competition pages. And when you're using our software, we would be happy if you put our logo on your cars and your reports. Thanks for watching. Thanks again, Prasanna, and hope to see you next time. Bye-bye.
Bye-bye.